very important topic for your NEET and your JEE mains, and also for your, CBSE, and in fact, all the boards, even the IB board. All right. So the topic of the day is capacitance, and we will see a situation which will help us understand, the concept of capacitance. So this is not some very complicated type of numerical, but the whole focus is conceptual, development. Okay. Okay. So let's see the situation. So if you have, a capacitor, which is represented by two plates, so you have two plates, and what you do is you charge them up, and they acquire a positive and a negative charge, and then if the so this is a capacitor, parallel plate system which you have, and the situation is that you introduce a metallic plate or a block, of some thickness T, and the distance between the capacitance plate is given to be D. And when you introduce this metallic block, the metallic block, as you might have studied, you cannot have any electric field, and when you do that, the what happens to the metallic block is the charges get attracted towards the plates of the capacitor. So the positive plate attracts the negative charges, and the negative plate attracts the positive charges. And the way electric field is generated inside an inside a metallic conductor is that completely cancels the electric field that actually exists between the plates of the capacitor. So this is your, the plates of the capacitor, these plates have an electric field, and that is where the energy gets stored. So if these are your plates of a capacitor, which are charged, the electric field, which is inside the parallel plate system, this represents the energy, which was provided by the battery. So all the energy appears in the form of electric field. Okay, this is very important concept to understand, that when you charge a capacitor, and using a battery, essentially all your, the work which is being done by the battery appears in the form of electric field, between the capacitor plates. So this is the electric field being represented. And when you introduce a metallic block, this metallic block, gets polarized, so to say, and completely neutralizes the electric field, which is due to the parallel plates of a capacitor. So if you talk about the electric field inside the metallic block, the E is 0, because you have an external, electric field coming from the capacitor, and then an equal and opposite electric field being produced because of this polarization of the metallic block. Okay, so the electric field net inside the metallic block is 0. And what we've done here is, in this example, is we've placed this metallic block centrally, between the two. So this is completely at the center. Okay, so if I draw axis, my metallic block is completely placed at the center of the two capacitor plates. Now let's talk about, what exactly is happening. So this part of the capacitor plate system, the metallic part, this width has absolutely no electric field, which means the electric field is now left between, this part, so you have plus minus charge, so you have some electric field which does exist here, and you can draw that. and then electric field becomes discontinuous, it is zero, and then you again have an electric field here, okay? So you have electric field here from metallic block, the charges on the metallic block, and the metallic, the parallel plate, which is negatively charged. So essentially what is happening is the electric field is appearing in this region and the electric field is appearing in this region, and middle of the capacitor where the metallic block is located, you have no electric field. So this part of the system, which is the metallic block, contributes, has no contribution towards, you know, when I say towards, I mean towards capacitance. It does not store any energy. Whatever is getting stored here and here. So if you were to look at the system, the system will appear like two, one capacitor, which is D minus A by 2, and the second capacitor, which is also, D minus A by 2. Because you can say it's T, because I used the metallic block, the width of metallic block is T, and the parallel plate, the total distance was D. So this distance plus this distance is D minus T. And since the block is kept centrally, this distance is D minus T by 2, and this is also D minus T by 2. So I'll just correct the terminology being used. So this is D minus 2 and D minus 2. So what you're essentially having is, you have the two capacitors, the capacitance number 1 and the capacitance number 2. These two are connected in series now. And this becomes 1 by C is equal to 1 by C1 plus 1 by C2 is equal to 1 upon D minus, since air is the medium, so you can write this as capacitance of the first one as K, which is in the case of air is going to be 1, and so K A by D. Okay, so the D is nothing but reduced to D minus T by 2, and the area, which is in the so to say denominator, right? So you can put the values of 1 by C1 can be written as D minus T by 2, and this becomes 1 by Ka, and 1 by C2 is equal to D minus T by 2, 1 by Ka, and you have to do 1 by C plus, so this essentially becomes, if you add these two, the equation number 1 and 2, so 1 by C1 plus 1 by C2 is equal to D minus T, and 2 multiplied by 2 because they're identical, so this gets deducted, and so this is your 1 by C, and C is equal to Ka upon D minus T. So you can see the capacitance has been impacted, because the capacitance should have been Ka by D, where D represents the distance, but now because of introduction of a metallic block, the capacitance, which should have been D, has been reduced to D minus T. So the capacitance of the system goes up if you insert a metallic block. Okay, the area doesn't change. The medium is in fact air or any other medium, which you could have in these two regions. You can write the dielectric, or so to say permittivity of those mediums in the formula. But here you're replacing that medium. In this case, air is being replaced by metallic block. So this sense should be out there inside your mind, that if you introduce a metallic block, you're reducing some place where the which will not contribute to storage of energy And the energy in the capacitance system is stored in the form of electric fields. If you have some gap where there is no electric field, that place does not contribute towards capacitance. So your capacitance, boils down to this region and this region. And since the width has reduced, the capacitance of the overall system, because of the reduction in width, and then you treat them to be equivalent of two equivalent capacitance which are in series. For series you apply this, and if this was a single capacitor, your answer would have been Ka by D, but now the capacitance has become Ka D minus C. So I hope you understood that the regions where the electric field goes down, don't, goes down to the extent of zero, do not contribute to the capacitance of the system. If you like this video, give me a thumbs up, and you can, stop it maybe and listen to it slowly. Thank you very much.